Okay, but that does not mean I will skip them. I'll try to be a little quick on those things. But if you think, we need to detail those things, please stop me. Okay. But again, I'm not going too fast anywhere. But some of the stuff maybe we think we know. So switching, very simple. It's a layer 2 device, and it uses MAC addresses because it's a layer 2 device. And the job, this is the focus. This is the primary focus. The job is to find the destination host. Now, with regards to routing, whatever we did, let it be HRP, OSP, or BGP, MPLS, whatever we did, our focus was to identify the destination networks, location of the destination systems. But when it comes to switching, its job is to find the exact host. Okay. So pretty much the whole day's discussion, at least major part of the discussion, is going to be how this is achieved. Okay. So we will have to understand how this exact function is done. Now we discussed routing just like that. Okay, we said router's job is to find the destination network, but how exactly will it do? We saw that. 4 steps, right? Packet gets into the router, calculate the destination network, look into the routing table. If found, send it through the exit interface, if not, drop. So similarly, I need to find out in the switching. So before we go there, we'll try to get the catch of the basic differences between hub, switch, and a router. Now, hub is a layer 1 device, which is a layer 2 device, router is a layer 3 device. Hub has no addressing schema, or otherwise I will say this, the function of a hub would be amplify the incoming signal and send to all other active ports. It has no knowledge of what is that signal, what is the type of signal, what is the meaning of that signal, nothing. It's just signal for the hub. So it just gets these raw bits signals and it transmits it out. Okay. Now it transmits it on all other ports except the port through which it received. I don't know, for some reason many people will be very specific about that point. Except the port through which it received. Yeah, that's obvious. Okay, but nothing wrong in saying it. So then, what is the job of a switch? As we just said, identify the destination host. And what is the job of a router? Identify the path, best path to destination network, the location. Now, because there's no identification for a hub, there's no addressing schema applicable, nothing applicable. When it comes to a switch, it uses MAC address. When it comes to a router, it uses IP address. More authentically, you should say logical address. But today with everything TCP/IP, IP address is what you can safely say. Okay. What next? With regards to the bandwidth is shared in a hub. So what do we mean by that? If I say I have a 10 Mbps 8-port hub, the total throughput I can have is 10 Mbps. That 10 Mbps is shared among all the ports. But whereas when it comes to a switch, the bandwidth is not shared. Meaning, if I take the similar example, now this time I say it's a 10 Mbps 8-port switch. the total throughput I can get is 80 Mbps. Because every port will now get 10 Mbps. Now some people say, okay, if it is a full duplex, then it is multiplied by 2, and so it's going to be 160 Mbps. Kind of true, yeah. Okay. So that is the capacity you can get because the bandwidth is dedicated to every port. Now, this is where I want to highlight one small point. Sometimes we call this some of the ports as uplink ports. Okay. So those ports technically have absolutely no speciality. Okay. Speed is more. That's what you will have. Generally, if you see a 100 Mbps switch, you will have a 1 gig uplink ports. And if you have a 1 gig switch, typical for very common, very typical for data centers, then you would see a 10 gig port. Nowadays, you are getting 25 gig, 40 gig, and 100 gig ports. For a long time, I thought only Cisco is producing 100 gig ports, which is totally wrong. Other vendors are also providing that. Very costly, but yes, 100 gig on a single port you can get. So these are called as uplink ports. And the reason why I want to highlight this is later you are going to learn about trunk ports. Okay, so that has a technical meaning. That has a technical difference with regards to other ports. Okay. So we will discuss that. And some of you may already know what it is, but we will talk about it. So uplink port is just English word, okay? It's not a technical word. It's an English word to say I'm connecting to some special device. I'm connecting to a server, so I call it as an uplink. I connect it to a router, so I call it as an uplink. I connect it to another switch, so I call it as an uplink. So if I'm connecting to some special device where typically you need more bandwidth. Why? Because more systems are communicating towards the other end. So that's why we call them as uplink ports. But again, it's just an English word. It has no sense. Generally though, when we say uplink, it generally means it has got higher bandwidth. So with that, I wanted to highlight this point. The bandwidth is dedicated. Each port will have its own bandwidth. When it comes to a router, I don't even have to say, bandwidth is not shared. Chennai to Mumbai, you have a 10 MB connection. Mumbai to Pune, you have a 200 MB connection. I don't know what. Every interface will have its own connection. You have a gigabit on the LAN, which has got 1 gig connection. Every port has got its own bandwidth. Okay, so after giving all these differences, people will ask you, okay, so tell me what is the difference between hub switch and a router? I thought I just told you that gave you the differences. You're still asking me what is the difference between a hub switch and a router? What do you mean? Now, in order to give the other differences, two very important terms and the concepts have to be understood. Broadcast domain and collision domain. Broadcast domains and collision domains. What are they? Let us start with the broadcast domain. Now, anytime you say domain, it's a group. So, how do you define it? If I have, let's say, systems connected to a hub or cascaded hubs, and if one of the systems send a broadcast message, who will receive it? That's the question. And the answer to that question is the broadcast domain. Let me officially define it. A group of systems are said to be in a single broadcast domain when they all receive a broadcast message. In the sense, when one of the systems connected to these hubs send a broadcast message, all the systems connected to that hub and the cascaded hubs, you may have another 20 hubs, doesn't matter. All of them will receive this broadcast message. First time, second time, every time. So this is a broadcast domain. So all the systems connected to the hub are said to be in a single broadcast domain. Can I break it? Meaning, can I say, okay, I will send a broadcast message on this system. Only these systems and these systems should receive. Nobody else should receive it. Can I break it? And the answer is no, you cannot break it. So when it comes to a hub, your hubs cannot break the broadcast domain. They just can't. The only way you can break the broadcast domain is break the hub. Like literally, cut the cable here. Okay. So you cannot break it. Okay, I know this stuff. What about a switch? So if I have a group of systems connected to a switch, when one of the systems sends a broadcast message, who will receive it? Everybody will receive it. A group of systems are in a single broadcast domain when they all receive a broadcast message. First time, second time, or every time? Answer this question, please. Is it first time, second time, or every time?
First time.
Okay. Any other answer?
Yeah, first time.
Yeah, Kalyan. Actually, by default, there is in all switches there is a VLAN 1. So there is a.
Right now, I don't know anything about VLANs. I'm just asking the default behavior only. So first time or every time? That's the question.
First time.
Okay.
Switches have first time broadcast and next time it is sending a unicast message.
Okay. The answer is wrong. This is a very, very, very common mistake people will make. Very common mistake. Okay. See, I had my doubts when I was learning switching. I had this doubt. Okay. And some of us know. I also know that. I know switch will broadcast first time. After that, it will become point to point. We know the stuff. We learned it. MAC address table, blah, blah, blah. We know it. So first time it will send. So why do I need a VLAN then? We also know VLAN. No? And by the way, if you don't know, don't worry. We will discuss that. But okay, then why VLAN? First time only it will send. No? After that, it does not need to send. So then why do I need a VLAN for VLAN concept? I don't need it. This was my thinking. Why? Why then VLAN is required? Very, very
Actually,
small detail. Wait a minute, I'll explain. Very, very small detail, which is unfortunately not our mistake. Unfortunately, the terminology mistake. And I want you guys to be very clear with that. I am defining the broadcast domain once again. It's a group of systems that are receiving a broadcast message. Now the key word is broadcast message. The definition is not broadcasting. Be very clear with it, and that too we are in switching class. There is a difference between broadcasting and a broadcast message. Those are two different things. Unfortunately, they look very similar. And that too when we use it in real world, we use them like as if there is no difference. Okay. Broadcasting. The other word for this is called flooding. Unfortunately, we don't use this word that much. Broadcasting is a phenomena. It's a style of sending, propagating the data. Okay. Broadcast message is a specific type of message where the destination is 12 Fs. It's a very specific destination. I'll ask you these two questions, and if you get the answer correct, we understood the difference between these two. First question. A system is broadcasting a message. A system is broadcasting a message. Who is the destination? Who is the destination? Answer.
12 Fs.
Okay. Any other answer?
Means there is no destination, but it would be sent on 12 Fs.
Okay.
All other systems which are in the same domain.
Okay. Wrong. Okay. And again, this is the problem, right? And that too, the more experienced we are, the more difficult to get the concept right, actually. Okay. See, in our mind, we use the word broadcast whenever we want to send a broadcast message. It's not like you're wrong. Technically, that's how you think and that's how you talk to people when you say a message is broadcasted. Okay, so you can understand that, I can understand that when we talk, so it's fine. Okay, but that's not right. I'm repeating the question again. When a system broadcasts a message, who is the destination? And the answer is, I don't know. I cannot answer that question really. I cannot answer. When I said a system is broadcasting, all that I am saying is the system is sending it to everybody. That's all I can say. I cannot say who the destination is. I have to ask you another question for this. What is the type of message? If the type of message is a unicast message, then the destination is one destination. If it is a multicast message, then the destination is a group message, whatever is between 224 to 239. And if I am sending a broadcast message, then it is 12 Fs. So if I don't give you the message which is sent by the system, I cannot tell who the destination is. I cannot tell. What just now happened is broadcasting, just flooding. Everybody is receiving. Now listen to the second question. That will give you clarity to the first one and the second. When a system sends a broadcast message, who is the destination? Can you answer this? Yes? Guys, are you there?
Yeah, anyone can be a destination. Anyone can receive that message.
Wrong.
Kalyan, actually, it has no destination or any knowledge about the destination. That's why it's sending, means it is broadcasting the message to all which are in domain.
No. Now my question is, when a system sends a broadcast message, who is the destination? The question very carefully. Very good, Putraj. 12 Fs. Now my information I gave is very clear. The message sent by the system is a broadcast message. The moment I gave you this information, now you know that it is 12 Fs. The system wants to talk to everybody. That's why it sent a broadcast message.
But sorry to interrupt you, Kalyan, but 2 minutes back, I told you that its destination is on 12 apps.
That is wrong answer.
Means what is
That
the
is
difference?
the wrong answer, because that time 2 minutes back my question was this. My question was, when a system broadcasts a message, what is the destination? That was my question. And the answer you gave is 12 Fs. You also said because the system doesn't know whom to send, it will put 12 Fs, you said. That's wrong. The question I am asking now is different. I want everybody to put very close attention to the question. These two are different questions. Are you clear, Deepak? A system broadcasts a message is different from system sends a broadcast message. Two different things. That is the clarity I want. Difference between broadcast message and broadcasting. Are you clear? Let me explain what I mean with a simple analogy. Deepak, when did you get up today?
Sharp at 10.
Okay. So in this message, in this question, who is the source? I am the source, right? Who is the destination of this message? Deepak is the destination of this message. Who received the message?
Everyone.
Everyone received. Right now, what happened is broadcasting. Flooding happened. Because we are all sitting in the same room, broadcasting happened. Flooding. Everybody understood what I said?
Kind of.
Now this message, everybody understood what I said. In this message, who is the source? I am the source. Who is the destination? 12 Fs. Everyone is the destination. My question is, everyone understood? My question is a broadcast message now. This broadcast message also everybody received it by coincidence. So the first message, Deepak, when did you get up? Second message, everyone understood. Both of them are received by everybody. But the first one is a phenomenon. It's a behavior. It's a way of propagation. It's just sent to everybody. But the message was unicast message. If I have to put it on the devices, it's even more clear. When system 1 tries to communicate to system 2, the message will be sent to the hub. It's a unicast message. Hub does not know who is what, where is what. So it will send it to everybody. Hub is flooding. Hub is broadcasting. When 1 is communicating to 2, hub does not know where 2 is. So it will flood. When 1 is communicating to 2 in a switched environment, it's a unicast message, right? When one is trying to communicate to 2 in a switched environment, first time switch does not know where things are, so it will flood. First time flooding will happen. And after that, it will directly send it from one port to another port, one port to another port. And this is what you guys told me, right? This is what you said first time it will happen. But listen carefully. What happened right now is unicast message is initially flooded, and after that, it has become point to point. Now, let me go back to the scenario. 1 is trying to send a broadcast message, not to 2, but it is sending a broadcast message. So destination is 12Fs. When the hub receives it, what will it do? I mean, it does not know 12Fs, it does not know anything. It will send it to everybody. First time, second time, third time, it doesn't matter. It will send it to everybody. Now, when 1 is sending a broadcast message, what will switch do? It will send it to everybody. Second time another broadcast message is coming. Where will it send? Destination is 12Fs. It's a broadcast message. So again it will send it to everybody. Third time, fourth time, whatever. Any number of times, because the message is a broadcast message, it will be sent to everybody. Yes, I know where 1 is, where 2 is. I know everybody in the network. In my fancy tables, MAC address table, blah, 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 and all that. Fine, I know that. But the message coming is a broadcast message. Well, else, I will just continue to send it to everybody. So the key here is this. Your broadcast domain is not based on flooding. It's not based on that. The broadcast domain definition is based on the broadcast message. Okay?
Got it, Kalyan. Now I got it.
So, whether it is a hub or a switch, first time, second time, any number of times, because the broadcast message is sent to everybody, and based on that only the broadcast domain is defined, both of them cannot break the broadcast domain. First time, second time, any number of times. Okay. So now I understood. Oh, okay. So tomorrow, the broadcast domain is, the broadcast messages are sent by applications. So in a big company, the broadcast applications are different for different business units. So if one application sends a broadcast message, it will go to other business unit systems. And I don't need to flood my broadcast message to all of them. So now I need a VLAN. Okay, now it makes sense. Because if it is a unicast, your switch would anyway break it. Your switch will anyway first time send, learn it, and then it will send it to the direct port. But in spite of learning all of that, broadcast message is still sent to everybody. No? That is what I want to break. That is when I will use the VLAN. Again, we will reiterate on this point later when we introduce VLANs. I'm just assuming that you know the basics of VLAN. Right. So this is the key point. By default, your switches will stop flooding, but they cannot, by default, break the broadcast domain. They can't, by default. So here, when it comes to a switch, your switch cannot break broadcast domain by default. Why do I say by default? By default, because we know VLANs are there, Right. We'll introduce that. So that is broadcast domain. Okay. Now the last thing is the router scenario. So when you have a router, and if a router receives a broadcast message, that's it. It's not getting propagated anywhere. It is going to stop right there. Your broadcast domain is broken by a router. Okay. So when it comes to a router, the broadcast domain can be broken. It's not can be broken. Say that. Router breaks the broadcast domain. And a very famous question, you know what the question is. When it comes to a hub or a switch, the number of broadcast domains is equal to 1. When it comes to a router, the number of broadcast domains is equal to number of interfaces. So that's that. Okay, so now I think I got what a broadcast domain is. It's not based on the flooding logic, it is based on the broadcast message. Whoever receives this broadcast message, they are all in the same broadcast group. Okay.
Kalyan, could you please repeat that? The means you were telling something about routers broadcast domain. Could you please repeat
Routers
that?
broadcast domain, the number of broadcast domains in a router is number of interfaces. So a broadcast message coming from this interface will not be sent to this. Similarly, a broadcast message coming on this interface will not be sent to any other interface. So in this particular example of 3 interfaces, the number of broadcast groups you have is 3, equal to the number of ports, number of interfaces.
Means depends on port.
Depends on the number of interfaces. Right?
Okay. Thank you.
All right.
And,
So now that's yeah.
and it includes the 7-way router, right? In the router.
It includes the
7-way.
yes. Logical or physical.
Okay.
Yeah. All right. So now we get to this other thing called collision domain. What is this? Collision domain. Here is the definition of a collision domain. A group of systems are in a collision domain A group of systems are in a collision domain when only one at a time can send data, or rather use the medium. Only one system at a time can come in that entire group. If that is the limitation, then all those systems are sharing a single collision domain. The reason why they call it a collision domain is because if 2 systems try to share or send the data at the same time, collisions occur. Okay. If I have a hub and a cascaded hub, if 10 is trying to communicate with 20, at the same time, can 30 communicate with 40?
Glenn, I can't hear you.
Yeah, for me as well.
Quickly detected that failure. What was the last statement you heard from me?
You were discussing about collision domains.
Okay. Just started, then I. Fine. Yeah. So the definition for a collision domain is this: a group of systems are in a collision domain when only one at a time sends the data. That's what a collision domain is. Meaning, if two systems in a collision domain, if they try to send the data at the same time, the collisions are inevitable. Collisions will happen. So with that, let us see the example of systems connected to a hub. So when I have systems connected to a hub, in this example, 10 is trying to communicate to 20, and at the same time, 30 is trying to communicate with 40. Okay, when 10 is communicating to 20 and 30 is trying to communicate to 40, will it happen? Okay, can that happen or not? Yes or no? Guys, are you there?
Yes.
Yes,
What
ma'am.
happened, Kalyan?
Okay. So what's the answer?
There will be collision.
There will be collision. Very good. Excellent.
Yeah, because it's half duplex.
Oh, okay. So now I have a switch. Same setup. I just changed the box name from a hub to a switch. And now, when 10 is communicating to 20, at the same time, can 15 communicate with 25? Can 15 communicate with 25? Yes or no? When 10 is communicating to 20, at the same time, can 15 communicate with 25?
Yes. They can communicate.
Yes. So when I said that, obviously, can 30 communicate to 40? Yes.
Yes.
Very good. So when it comes to a hub, your hub cannot break the collision domain, but whereas when it comes to a switch, your switch can break the collision domain. Okay? Discussion over. Unless you have any questions. Unless you have any questions, the discussion is over. No questions? That's it? That's all? For a simple thing like broadcast domain, we had a bit of discussion understanding the difference between flooding and broadcast message. Collision domain, over? Okay, you don't have any questions. So I will ask you the questions. How switch is able to break the collision domain?
Every port is a different collision domain in switch.
That is the answer. Now my question is how? Once you explain me how it happens,
Yeah, actually,
then you can tell me that this is a different collision domain. You have to see, it's like this, Deepak is a good boy, yeah? Okay, but because you said he's a good boy does not make him a good boy. Because he does things like this, that's why he's a good boy, right? Because a switch has the intelligence of breaking this collision domain, whatever that intelligence is, you have to explain me. That's why switch is a different collision domain. Every port is a different collision domain. You have to tell me that. Because we said switch is every port is a different collision domain, it's a different collision domain. I can't buy that.
Better means advanced hardware than hubs. It has, I think, ASICs and other things as well.
Okay, so what does that mean? I cannot say no to that answer, but you have to explain me. Okay, you cannot tell me switch is intelligent. But you have to tell me how why and how it is.
Based on MAC addresses, actually takes the decision based on MAC addresses.
Very, very classic wrong answer this is.
And
very classical wrong answer. Okay, very.
There are ASICs used in switches which separates these collision domain.
I cannot say no to that, and I think you are very close to what I am expecting. Definitely, you are very close to what I'm expecting. But still, can you elaborate on that?
Actually, the switch will sense the wire if any other host is sending on that port or not. It will sense the wire. If nobody is sending, it will send it. Otherwise, it will. This is how it will stop the collision.
This is also another answer I was expecting, which I would like to explain. Very close, very close. Okay, 2 answers I got. All right. So let me first explain this. See, there is a very classical mistake people will make, and Deepak gave that answer actually. Okay, we think switch is learning the MAC addresses, and therefore it will only send it to that respective port, and therefore the collisions will not happen. A very, very, very false, illusion we get. Let me tell you why. If you go with that argument, switch will learn the MAC addresses. You also know first time switch also does not know where the systems are, right? So, first time when 10 is communicating to 20, and first time when 15 is communicating to 25, whether it is connected to a switch or a hub, it will be sent to everybody, right? Because switch also, first time, it does not know where the systems are. First time, it has to flood. So, initially, hub and a switch are the same because they fled. So, if you go with that argument, then for the first time, switch should have collisions. No? Hub and switch both should have collisions for the first time. Afterwards, switch will learn the MAC address and it will break the collision domain. Okay, but for the first time, switch should have it. No? And the answer is no, switch won't have it even for the first time. So, first thing I want to be clear is, the collision domain broken by the switch has nothing to do with address learning, forward and filter decision makings. It has nothing to do with it. First, I want that to be clear. Everybody clear? Okay. So now we know that is not the reason. What is the real reason? I don't want to answer the question. No, I don't want to answer the question how switch is breaking collision domains. I don't want to answer that. I have a confusion here itself. Within this hub environment, I was thinking, okay, what is wrong? When 10 is communicating to 20, 30 cannot communicate to 40, I said, because it's all in a single collision domain. Only one at a time can communicate. Okay, but when 10 is sending the data, how will 30 know that 10 is sending the data? And don't say it is sent to everybody. Okay, because I'm literally going into the wire. Right now the data is on this wire. It still did not even come to the hub. So when one system started sending the data, nobody should send. So again, going back to the same question. So how will the other systems know that somebody is transmitting the data? How will the other systems know? And the answer to that is Csma Cd. This is an Ethernet technology that is running in the MAC layer, which is used to detect who is transmitting, who is not transmitting, and it is the one which is used to seize the medium, take access of the medium and use the medium. Carrier sends multi-access with collision detection. This is the algorithm that is running on your Ethernet cards. Any Ethernet card. It could be a card on your system, wherever it is. Okay. Now we have to understand what this is, like how this Csma Cd works. It's a very, very simple algorithm. Okay. What it does is, when a system wants to transmit data, the system wants to transmit data, what the system will do is, the system is going to send a sample signal. It will send a sample signal and monitor the effective echo disturbance. It will be monitoring the effective echo disturbance. Okay. Now, what happens with that is, if the effective echo disturbance is found, wait for a random period of time and again send the sample signal. If the effective echo disturbance is not found, use the medium for a period of time and again send the sample signal. That's it. This is all what it does. So I will send a sample signal. I will see if the media is free or not by looking at the echo disturbance. If there is no echo disturbance, effective echo disturbance. If there is no effective echo disturbance, I'll use the medium. So if I have like 1 GB file to transfer, I will not take the medium for that entire 1 GB transmission. That's not the way it works. I will take the medium for some time, for a few milliseconds. And then I will release it. Again, I will send the sample signal. Okay. So this way, release and take, release and capture, release and capture. That's how I use the medium. During the release and capture of the medium, I'm going to check whether anybody else is transmitting or not by sending a sample signal and waiting for the echo disturbance. Okay. This is what happens with Csma Cd. Now, with CD, with collision detection, what happens extra is, when I am transmitting the data, I will also look for an echo disturbance. So while transmitting the data, if I have an echo disturbance, I will immediately, abruptly stop the transmission. Again, wait for a random period of time and again send the data. So that is what I do. Okay. Now let us try to put that in our setup and see. So here 10 wants to, 10 is transmitting the data and 30 wants to transmit the data. Okay. So if this is the case, what happens? When 30 wants to transfer the data, what it does is it is going to send a sample signal. It is going to send a sample signal out. Now the hub, it just amplifies the signal and send it to all the active ports. There's nothing special about that. It does not even know the difference between a sample signal and a data signal. It just signal for it. So what hub does is, hub sends this sample signal to every corner of the medium. And when it is received by the hub here, it is going to send the sample signal to every corner of the medium. So even when the data is right here, it did not even come to the hub. If the data is right here, the sample signal will collide with the data signal. Okay. The sample signal will collide with the data signal. So here are the three possible collisions that can happen. First, two sample signals can collide. Right? 10 also wants to send the data. 30 also wants to send the data. So both will send sample signals. So both the sample signals can collide. Now when both sample signals collide, who will face the echo disturbance? Who will face the echo disturbance? The answer is surprising. No one. Because the sample signals are going with such low frequencies. Okay. There is a disturbance, okay? Any medium you send any data, you have some noise. So that's kind of an echo disturbance to you. But the reason why they don't look at that as a disturbance is because it is not effective enough. It's not too much of a disturbance that I think that there is somebody accessing the media. It's not going to give such an impact. Now, because of that, there is a second possible collision, and that is two data signals collide. So what is happening? 10 wants to send the data, so it sends a sample signal. 30 wants to send the data, so that will also send a sample signal. Now both the sample signals collide, but there is no disturbance detected because it's just a low frequency signal. So now what they do? Both of them will start sending the data. Now when both of them send the data, with the CSMA only, that's it. They will send the data, the collision will happen, and they have to retransmit. But with collision detection, with the CD, as they transmit the data, they will also see if there is any echo disturbance. And if they see that the two data packets are collided, both the systems will detect the disturbance because data is going on a higher frequency. So now what they do? Both will abruptly stop the transmission. Okay, they are sending half the frames, doesn't matter. They will immediately stop the transmission and they wait for a random period of time. Okay, and the random is very, very important. Because if both of them wait for exactly 5 milliseconds, every time they will collide, right? So they wait for a random period. If I go a little deeper, there is an algorithm running there. It's called random back-off algorithm. Again, we don't have to dive that deep, but that's an algorithm which is going to generate a random weight value. Okay. So that way they randomly wait for a period of time. And the third possible collision that can happen is data signal and sample signal. They both can collide. The example I was giving you here, like when 10 is transferring the data, at the same time, when 30 wants to transfer the data, what happens is 30 will send a sample signal. It will be going to every part of the medium. And even if the data is right here in this cable, it is going to collide with the sample signal. So the sample signal will face the disturbance. The data signal will just move on. Okay. So again, data is going on a higher frequency, sample signal is going on a lower frequency. So the one that is coming with a higher frequency just does not face any disturbance. It will just transfer the data. But the one going with a lower frequency, that will detect, oh, okay, somebody is transmitting the data, so I should wait for a random period and try again. This is how Csma Cd works. And this is the reason why only one at a time can communicate when you connect the systems to a hub. It has nothing to do with half duplex or full duplex. Okay. Using a hub itself is very rare today. Even if somebody is using the hubs are also having a full duplex mode of communication. Okay. So really does not matter. The real challenge is, it's not about the duplexity. The challenge is that the sample signals are going everywhere. Okay. Okay. Now I got the Csma Cd and the hub. Now I think I should go and talk about the switch. Okay. What is so special about the switch? We say switch is intelligent and all that stuff. What is that? What is that intelligence that is making switch break the collision domain? How can a switch break it? How can I have parallel communication in systems connected to the switch? How is that possible? Because end of the day, hub or a switch, both are Ethernet technology only. How can switch do the magic show? I will give you 4 different scenarios and explain the reasons one by one. Okay. First, when 10 is transferring the data, at the very same time, can 30 send the data? Or maybe can 15 send the data? At the very same time, can 15 send the data? And the answer is yes. Why? How? The first reason is every port of a switch is running Csma Cd. Every port of a switch is running Csma Cd. Now, because of that, when a sample signal is sent, so the logic does not change. Csma Cd is just the same. It works exactly the same. So when 15 in this example, when 15 wants to send the data, it will send a sample signal. By that time, 10 is already transmitting the data. Okay. So when 15 sends the sample signal, where will it go and terminate? It will terminate right at this port. Because every port of a switch is running Csma Cd, the switch has the intelligence of differentiating sample signal versus data signal because both are talking the same language. Same algorithm is running. So the sample signal is terminating right at the port itself. In English, what does that mean? In English, it means I am checking only this part of the medium. I am not checking the whole network. Only this part of the medium is what I am checking. Okay? So that's why parallel communication into the switch. Parallel communication into the switch is happening because of Csma Cd. So parallel communication into the switch. Okay. So that's why when 10 is communicating, sending the data, 15 can also send. Because this port is free, I can send. Okay. But what about 30 communicating to 40? At the same time, 50 also communicating to 40. 50 also communicating to 40. So will collisions happen on the port? Or no, I'm not going there first. Okay, I'm going with this. When 10 is communicating to 20, 15 is communicating to 25. Will collision happen in the switch? That's where I want to go first. In the switch, will the collision happen? Not on the port level. I will come to that as a third scenario. As a second scenario, will the collision happen in the switch? No. Why? One of you gave the answer, and that is because of ASICs. So because of the ASICs, I can have parallel communication within the switch. So what do you mean by this ASICs? Application specific integrated chipset or circuit, whatever they call it. Okay. What is this exactly? Now this is like on the motherboard, through the ASIC, through this circuit, we will have, in today's environments, you can see a full mesh of connections. Like from every port to every port, you have full mesh of circuitry. Once upon a time also, we all used to have this ASIC connecting to the CPU, and from there they are sent to other ports. That's very old stuff, but even then, parallel communication is perfectly all right in the switch because they're not using this one centric wire of some sort. It's not like that. It is full mesh of circuitry or a centralized circuitry to this CPU or whatever. But in today's world, it is physical circuitry is there through the motherboard to all the other ports. That's why when 10 is communicating to 20, parallelly 15 can communicate to 25. Absolutely no problem, because this will be going on a separate circuit physically on the motherboard, and this will be going on a separate circuit, completely a separate circuit. So that's why parallel communication within the switch is possible because of the ASICs. Parallel communication into the switch is possible. They can even start sending parallelly because Csma Cd is running on the port level. Now to going to the third scenario. Okay, how about parallel communication to the port? Like 30 is communicating to 40. At the same time, 50 is also communicating to 40. So now the question is, can I have parallel communication to the port? So will collision happen at the port level? And the answer to that is no. Why? And the third reason is buffers. Okay. So every port of a switch is almost like a NIC card of its own. It has got inflow, incoming buffers, and outgoing buffers. And every port maintains those buffers. Depending on the hardware, it could be, size can vary depending on the hardware you have. Okay, so here is the thing. When the frame is coming from 30 to 40 and 50 to 40, maybe 3 frames are coming from 50 and 3 frames are coming from 30. For example, the buffer here is 5 buffers. So 5 frames I can hold. So how many frames are coming? 6 frames are coming. But I can hold only 5 frames. So do I have a frame loss? Data loss is there? Yes, I have a data loss because my buffer size is less. But that is not because of a collision. It's simply because of buffer overflow. That's it. Collision is not happening because I keep them in my buffer, stack them in my buffer. So that's why the collision is not going to happen when you try to communicate parallelly to the same port. Okay, what about the last scenario? What if I am trying to communicate from 10 to 20? At the same time, what if 20 wants to communicate to 30? Now, the previous example was same direction. Both systems are communicating to the same port. Same direction they are coming. But now this is opposite directions. 10 is coming to 20. 20 is going towards 30. So now will the collision happen here? When the data is coming in opposite directions? Here, there is a condition. Is it full duplex or half duplex? If it is full duplex, there is absolutely no problem because there is a separate TX RX wire physically going separately, and there is a separate TX RX wire going in the opposite direction. So any transmission done from this switch port to the NIC card, it happens on this wire, and any transmission from the NIC card to the port is happening on this wire. Separate wire is being used. That's what makes it full duplex. You have 8 pins, right? So if that is the case, I don't have any collision happening. But for the sake of argument, if this is half duplex, so there's only one TXRX, they have to use that for the data transmission. Only one wire, half duplex, one way at a time. And then both want to transmit at the same time. Well, you have put me in a corner and asking me, will collision happen? And the answer is, yeah, collision may happen. Okay. There's no magic show here. Collisions may happen. Maybe 1 in a million. Okay. So it's not an effective thing. And remember, I am coming into this case if it is half duplex. I mean, today nothing is working half duplex connecting to a switch. We give examples, some documentations will say old, what is that? Old cameras, old access points. They'll give those examples in the book, in the document, but practically, come on, you are not seeing them today. Okay. But again, for the theoretical purposes, for very corner cases, yes, if you have a half duplex switch connecting to another side and both of them simultaneously want to transmit, definitely collision can happen. Okay. So just to summarize, how switch is breaking the collision domains. Because Csma CD running on per port, parallelly you can send the data to the switch. Because ASICs have a full mesh connectivity from port to port, parallel communication in the switch can happen. And because buffers are maintained on a port by port basis, both incoming and outgoing buffers, parallel communication to the port is possible. Because of these 3 reasons, you are able to, switch is able to break the collision domains. Are we clear with this? Yeah. Okay. Guys, are you there? Now, please don't say the connection was lost.
Yes, Kalyan.
Okay, good.
Okay, we can hear you.
All right. Now, here is a kind of, quote unquote CCIE level question. If your port is running full duplex, okay, if your port is running full duplex, do you still need CSMA CD on a per port basis?
I think no.
Yes, very good. You don't need it. Okay, so after telling all of that, this is the subtle detail, small detail. See, you took a port, this is one port, okay? This is just one port. But if you look at the wires, there is this TX separate and RX separate for transmitting data from the switch to the NIC card. And there is a separate wire, TX, RX, transmitting from the NIC to the switch. Okay. So because you're working in a full duplex mode, you don't have competition for the physical wire. This is separately going on, this is separately going on. Okay. So because of that, you don't see any commands in a switch to enable CSMA CD, to disable CSMA. You don't see such commands. The moment you configure this as half duplex, or operationally if it becomes half duplex, automatically CSMA CD will be running on those ports. And if it becomes full duplex operationally, automatically the CSMA CD is disabled on the port because you don't need it. Why? Because physically you use separate wires. There's no competition between the physical wires there. That's why. Okay. So, somebody who wants to truly test your skills on this logic, they will ask you this question. Okay. So just keep a note of that. All right. So with this,
Sanjan,
yeah.
I have to ask one thing, that if my both the switches are communicating on the full duplex, I mean on
both switches.
On both end communication is in the full duplex.
Yeah.
So still I'm getting RX error and FCS error. So what could be the reason?
That could be the NIC card problem.
And even I have changed the interface for testing. Like suppose on one of my uplink 24, there was error, and I have just
you changed the port from 1/1 to 1/2, or you changed the port from Ethernet 0 to Ethernet 1.
No, I didn't get 1/1.
1/1 and 1/2 are the switch ports.
Yes.
Ethernet 0, Ethernet 1 are the NIC cards. Which one did you change?
I have changed 1/1 to 1/2.
Then the problem is on this card.
Okay.
If you have changed this one, still seeing the same effect, then the problem is on this one.
Okay.
If you have changed 1/2 and Ethernet 1, then the problem is with the application, reinstall the application.
Okay.
Yeah.
Kalyan, I think there might be issues, some connectors, cables. Am I correct?
That also
that was also considered, of course.
That could be the reason, but also got changed the cable and SFP modules. Still observable.
Once you have SFPs in the picture, that is also becoming another constraint. End of the day, whatever we talk technically, when it comes to physical issues, right? It's always trial and error. You buy a 150 rupees NIC card, you buy a $1 billion NIC card. Same logic. Trial and errors. Yeah.
Okay.
Physical issues, right? Physical to data link issues. That's always the case.
So Kalyan, if we have half duplex on the port, then in a real scenario we are having a packet loss. Packet loss.
Csma Cd is running, so you can anticipate a couple of things. Collision resulting in packet loss, delay because I have to wait for the transmission on my side. So two things you can expect.
Then what is the benefit of collision detection here? Why if I use the collision detection on a half duplex port, then we should not get the error.
What do you mean you should not get the error?
No, I mean if I using half duplex, if we have a half duplex on the port,
okay.
What is the benefit of Csma Cd here? We already get the packet loss. We already get the collision.
Oh, hold your guns. This is running with half duplex. Okay.
Yeah.
So if it is running with half duplex, what we said, we will have Csma Cd running.
Yes.
Okay.
Yeah.
And what will Csma Cd do?
Collision detection. Yeah.
No. Give me clear answer. That is before you attended the class, you can say CSMA will detect the collision. But after attending the class, you have to be more clear, na? Tell me what it will do. The answer is right on the board. Send a sample signal. Monitor the effective echo disturbance. If found, wait for a period of time. If not found, then only send it for some period and again send a sample signal. This is Csma Cd, right?
Okay.
So now you have some frames here and you have some frames for the NIC card also. System is ready to send some frames. This side switch port is also ready to send some frames.
Okay.
If I don't have Csma Cd, they just send. Nothing to check. They'll send. Okay, I'll send. What happens? 10 out of 10 packets will be collided. 10 out of 10 packets will be dropped. 10 out of 10 packets should be retransmitted.
Okay.
That's why I have a controlled mechanism. Okay, you want to send? I want to send. I am the NIC card here. When we want to send, we both will first send a sample signal. By that time, already if this guy is sending, I will wait. If this guy is sending, this port will wait. What can happen is, both can send a sample signal and both can also send the data signal and both can also collide. Which means, I'm just giving you a very rough example, okay? Which means maybe 5 out of 10 packets will succeed and 5 out of 10 packets will fail. So you cannot argue saying, anyway 5 packets will be dropped, na? Then why will I run Csma Cd? If you don't run Csma Cd, 10 out of 10 will be dropped.
Okay.
Making sense?
Yeah, got that.
All right. But anyway, this is a completely theoretical discussion. Today, if somebody is using a half duplex, throw that box. Literally. I mean, come on. Yeah. All right, guys. So we will take a break. We will come back and then we will continue the class. Okay. So we'll come back by, let's say, 11:55. Now let us get into the switch functionality itself. Now there are 3 major functions. Now I should tell this, end of the day, the function is only one, okay, which is to identify the destination host. How that function is done, that is basically 2 steps. And the third is another function which is required. We will learn about it. The first thing is address learning. Next, forward and filter decision making. And the third one is loop avoidance. So I think I will go a little fast on this, but again, stop me if you think I'm going too fast. So let us say we have these systems, MAC addresses or 10, 20, 30, 40, 50, 60. And let's say that these are the port numbers. 2, 3, 4, 5. And this is port number 25, 26, let's say. So what is this? What's going to happen with this frames once they come into the switch? So here is the thing. Once a frame comes inside, the first thing that happens is address learning. What switches will do is switch 1, switch 2. What they'll do is they will maintain a table called the MAC address table. Like everybody knows this. It just right. Yeah. So it's a MAC address table. So it contains the source MAC address and the corresponding source port number. It will not learn about the destinations. It only learns about the source. So the source MAC address in this case is 10. The source port number is 2. So we'll learn the addresses. So that's the process of address learning. Learn the source MAC and the source port and put it in this MAC address table. Now, once it learns the MAC address of the source, then what it does is it will look for the destination in the MAC address table. Do I know where the destination is? Now, you're trying to communicate from 10 to 50, for example, or maybe 10 to 40. So I will look for the destination MAC 40. It's not there in the MAC address table. Now, because it's not there in the MAC address table, I am going to flood. Except the port through which I receive, I am going to send it to all other ports. So it's being sent to other ports here, eventually reaching the switch 2. Now, once switch 2 receives the frame, it also goes through the process of address learning. So any frame comes, I'm going to learn the source MAC address and the source port number, which in this case is 10, the source MAC, and the port number is 26. I don't care where it is connected to switch 1. I don't even care from which port of switch 1 I'm receiving it. What matters to me is how am I receiving it. So I am receiving it on port 26, and that's my outgoing port. So that's how I learn the source MAC address and the corresponding port number. So again, I learned it and I put it in my MAC address table, and I will look for the destination in my MAC address table. At this point, the destination is 40 and I don't know where it is. So because I don't know where it is, I will send it to all other ports except the port through which I receive. Now, because I received on port 26, I will send it on all other ports. Now, hypothetically, let us say there are another 20 switches here. Will it be sent to all the other 20 switches or maybe 200 switches? Will it be sent to all the 200 switches? And the answer is yes, it will be sent. Now, because I don't know that it is connected directly to me on port 1. I don't know that. So I will send it to every other port. Flooding is happening everywhere. Okay. So once I send it to everybody, eventually the destination, in this case 40, is going to receive that frame, and now it is responding. When the response is sent, this 40 becomes the source and 10 becomes the destination. So what I will do, When the frame comes from 40, I will learn the source MAC address and the corresponding port number, which is 1 in this case. Again, I will look for the destination. When I look at the destination, which is 10, I know exactly where it is. Now, because I know exactly where it is, I am going to directly send it to that port. This is where the second function kicks in. When I don't know where the destination is, I forward the frame to all the ports. When I know where the destination is, I filter in all the ports and send it only to that corresponding port. So in this case, the return frame is sent from 1 directly to 26 because it is going to 10 and I know where 10 is. So the frame comes to switch 1. Switch 1 learns the source MAC address and the corresponding port number, which is 25, because I'm receiving it on that port. It will again look for the destination, which is already there in the MAC address table. So it will directly send it from here to that respective port. Now this is where flooding becomes a point-to-point connection. This is the advantage. Flooding is stopped after the initial learning. Once I learn the MAC address of the destination, I don't flood. Okay. So the frame directly comes to port 2 and therefore directly to system 10. Now, here is the thing. The second frame is coming from system 10. When the frame is coming again, the second frame is coming from system 10, the question is, will I again learn the source MAC address and the corresponding port number? Should I again learn it? Yes or no? Answer, please. Should I again learn the source MAC address and the corresponding port number? Guys, are you there?
No.
Okay. The answer is yes, it will learn. It's very important to know that. It will learn. Every time I get it, I will every time learn it. And for all of these entries, individually, each entries will have a 300-second default ideal timer. This is what we call the MAC aging time, which is 300 seconds by default. The MAC aging time.
Sorry, Kalyan. Once I learn the MAC address, it will be updated in the MAC table, right? MAC database.
Exactly.
So you mean to say certain time period it will be removed from the MAC database?
Exactly. 300 ideal seconds. Keep that in mind. Okay. So this is where the timer is important. This is where relearning is important. Okay. So what happens is the moment I learn this MAC address, example 10 on port number 2, immediately next time I get a frame. Okay. First of all, let me tell you this. As soon as I learn this MAC address, my timer starts counting down like 300, 299, 298, so on and so forth. It is counting down. Second frame I receive, again I will learn it and reset the timer to 300 seconds. Again, I will count down. So as long as there is active communication with this system, I will continue to maintain this in my MAC address table. But for 300 ideal seconds, that means 5 minutes, no frames are coming from this system, I will remove that entry from my MAC address table. It's only a temporary cache. Are we clear with this?
No, in the practical scenario, what I have faced is, let's say when the one of the IP phone is connected, okay, and the user is switched off. And tomorrow if they come and log in, so I will tag the MAC address and then if I give the IP for MAC address, I'm learning the same port. Let's say past 0/1 today I'm learning, and then tomorrow if I track it, I was learning the same interface. Sometimes I used to clear the MAC entry, clear IPR for that particular IP phone IP, which I have faced it. So in that case, why that MAC address was not removed from the database on the switch?
Okay. First thing, two things I have to clarify for you. First thing, you are clearing the ARP entry, right?
Yes.
Not the MAC entry. ARP table is IP address to MAC address mapping. This is an ARP entry. MAC entry is MAC to the port number. This is the MAC entry. Because you cleared the ARP cache does not mean the MAC entry is removed. You're not even touching it. That's the first thing you should be clear. Second, let us say you have cleared the MAC table. Let us say you cleared it, which you can do. Okay. If you clear the MAC entry, if you clear that, there is very likely chance, okay, 99.9% of the time, there is a very likely chance your system is sending something, and that too you are saying IP phone. IP phone will be sending something every time, right? Even if I receive a single frame, again I will learn it. It's very difficult to catch that. In a real world, it is very difficult to catch because in a real world, an ideal PC is very difficult to find. Some application is running, right? You have a server, you have a client, whatever, something is running on that. At least in the boot process, initially you started the system or a phone, whatever. When you initially start, initially some control plane protocols will be running, right? So, if it is not a silent receiver, we call that as silent receiver. If you don't have a silent receiver, obviously it is very difficult to catch it. What you do is next time, you remove this MAC table entry, not the ARP, because ARP you remove, nothing has changed in the MAC table, right? You remove the MAC, immediately give the command, like immediately, hope you find it, right?
Yeah.
Okay. All right.
Yep, got it.
All right. Okay. But again, silent receivers are very rare in the environment, but it is possible to have, at least in theory. All right. So with that said, the entry is going to be always learned and always refreshed. Okay. When it comes to data center, nowadays the timers are 1500 seconds. Again, it depends. For ACI, it is 1500 seconds, and for regular switches, it is still 300 seconds. But again, depending on the model, you have to find out. One or the other, there is a timer that is set. Most often, you see 300 seconds. So every time you learn, you refresh the timer. Okay. The reason why I have to learn every time is, okay, today it looks consistent here, but tomorrow, because of this virtualization and all the fancy stuff, maybe that system is moving from here to somewhere here. Maybe it's moving from here to somewhere here. I don't know, right? It's a VM's MAC address, maybe. So I always have to learn the latest entry, always. Okay, so that is what happens. So many people think, okay, once I learn it, I don't have to learn it again until the timer is over, which is wrong. Okay. Right. So now you know the process. So I learn it once again, and again I look for the destination MAC, and it is still there. So I will send it directly to port 25. I will learn this MAC address once again, and then I will look into the destination MAC. It's still there. So I will directly send it from here to this port. This is what happens with address learning and forward and filter decision making. Okay. Address learning is learning the source MAC addresses. Forward and filter decision making is looking for the destination MAC in the MAC address.
Kalyan, can you hear me?
Yeah. Can you have something to ask?
Hello. Hello, Kalyan. Hello.
Akhil, are you speaking by any chance?
Yes,
I'm not
yes,
hearing.
yes, yes. Yeah. The Mac aging time we have increased in the data center.
Guys, is it only for me or everybody? Are you listening to Akhil's voice? Yeah?
Hello.
No, we can't hear.
Oh,
Yeah, now we can.
Hello.
okay. Okay. Sorry, thought I have it. Akhil,
Kalyan.
we are not able to hear you. In case you want to say something,
Yes, yes.
or maybe you're.
Hello. Yes, Kalyan.
I can see Akhil speaking again. I can't hear.
Okay.
Akhil, confirm in the chat.
Yeah.
In virtual switching, well. In virtual switching, everything is done at the logical level. Now there is technology called VMFX. There is technologies where you have direct IO. There are a few things which you can do with V switches. But it is always going to be kind of a software-based technology. Okay, more or less. Okay, so there's no such concept of a Csma Cd. There's no such concept of FTP. Nothing of that nature is going to be there in a virtual world. Okay.
Okay.
Now said that, there is competitive technology in VMware. Okay, one of them is called VMware NSX. Okay. So there is these things called, now we know ACI, right? At least we know the word ACI. 1 year before ACI came, I think about 7 years now. I lose track of time. 6-7 years ACI came, and 1 year before ACI, VMware introduced NSX. So NSX actually came first into the market. Only after that ACI came. Both of them are identical technologies. Okay, ACI is physical world, NSX is virtual world. So when you go into such technology, you have equivalent concept of full duplex, trying to transfer to both, but everything is happening on the virtual environment. You don't really see the exact things happening in the VMware. So yeah, generally speaking, no, you don't have such concepts. You don't have concepts of STPs, full duplex, things like that. But at the same time, in the advanced technologies, you may see a similar thing happen.
Okay, thanks.
All right. Okay, so with that said, without thinking too much, what happens if this goes down? What happens? Nothing. Switch 1 and switch 2 systems can't talk to each other. That's all. So which is a problem for me, and therefore what we did is we decided to connect these two with another cable, maybe 27, 28. So now if I have redundant connections so that I can use, multiple, in case one goes down, I can have the other resiliency. So for that reason, I've connected another link. Now let us see what is going to happen. Let us see like 20 trying to communicate to 60 here. Okay, or maybe 20 to 50, let's say. 20 communicating to 50. The frame comes to switch 1. It will learn the source MAC address and the corresponding port number. It looks for the destination 50. It is not there in my MAC address table. So I will send it to all the ports except the port through which I received. So I will send it on this and on this port. Because I have two links connecting switch 1 to switch 2, the very first problem I'm facing is duplication of the frames. The frames are getting duplicated. Okay. When the frame comes here, it is coming 2 times. The source MAC address is 20, but they is trying to communicate to 50. And what will be the source port number? It cannot be both. So it can be either 26 or 28. Which one? It's all a matter of timing, right? So I learned it on 26. Next millionth second, I learned it on 28. So I will always take the latest, right? I will always refresh the entry, right? So in this example, I don't care which one, just randomly picking 26. So because of the duplication of the frames, the second problem I am facing is inconsistency in the MAC address table. One time it is 26, one time it is 28, it is keep on shuffling. So now I have to send it. I have to send it, I have to look for the destination. And I look for the destination 50, I don't see it in my MAC address table. So I have to send it to all the ports except the port through which I received. So I will send it here, I will send it here, I will send it here. And I will also send it on port 28. Because according to my MAC address table, 26 is the port through which I received. Now, if you said 28, I would have sent it on 26. One way or the other, the same frame with the source MAC address 20, destination 50, the same frame will come back to switch 1. Now, when the same frame comes here, what will switch 1 do? Oh, 20 is the source MAC. Port number is now 27. Why? Because I received it on this direction. I always take the latest update. Okay, so now I received it on 27. Freeze the screen and see what is happening at this point. If anybody, for example 30, tries to communicate to 20, see what happens. The frame will come from 30 to the switch. Switch will see the MAC address table. Okay, 20 is connected to 27. So I will send the frame here. And according to switch 2, 20 is connected to 26. So the frame is sent here. And now you have a routing, switching loop. So this is the final effect of it. You're going to get switching loops because you have inconsistency in the MAC address table. Now, when this is happening to millions of packets, millions of frames, they call this as the broadcast stops. So this is dangerous, right? So I just wanted to connect one other connection, one other switch, one other link, just so I can get redundancy. But because I connected, I am facing all these problems. So what is the solution is, I need to have physically multiple connections, but logically only one active at a time. Only one should be active at a time. That is what I want. That is what I want to achieve. And this function of connecting physically multiple cables and logically having one active connection is what we do. And that function is called loop avoidance. And this loop avoidance is done with, everybody knows this, right? STP. So how is loop avoidance done with a switch? In a switch, it is using STP. So the question now is, how is STP working? Okay. That is the discussion pretty much for the whole day from now on. Spanning tree protocol. Now, before I talk about this, I want to share my opinion on this. Okay. That does not mean you should not concentrate on whatever we are discussing. I don't know how old you guys are. Must be not that young. Maybe, again, I don't know, okay? As far as I am concerned, I am very old. When I did my CCNA, I was learning IPX. IPX was there in the CCNA curriculum. Okay. We did not learn much. We did not concentrate much. It was just a miscellaneous topic because IPX is only used in certain places. Okay. So we never bothered about it. And today, do you even mention something called IPX? IPX, SPX architecture. There used to be this developed by Novell, if I'm not wrong. So TCP/IP was there, IPX was there. Some networks were using them. So it was like that. Today we don't even talk about it. Like IPX, what is that? Some old, outdated protocol technology. 10 years from now, this is my guess, my strong prediction. 10 years from now, the kids who are learning this networking, they will say the same with STP. That's what they will say. STP? What? That's these old people used to use it without intelligence. They used to work like, so they will say that. Okay. We ran this protocol for 30 years now, like literally 30, 35, 40 years even. We ran this. But in the last 10 years, I would say, people started moving away from STP. And in the last 6-7 years, LAN technology is trying its best to avoid STP. And data center almost succeeded at this point, almost. Still, there are many networks with STP running there. But eventually, 5 years from now, I think STP is like taken away from data centers. Enterprise, it may stay for a long time, a little longer, but eventually, STP is like, okay, nobody cares about it. It would be like that. Again, this is my opinion just before I talk about STP and the glory of it. With that